Hello everyone, today I'm going to tell you another example of extreme value analysis. So this we'll use the package called WAFO. The WAFO I think is quite useful for the oceanography or coastal engineering. The data I'm going to use here is the wind speed data. Those are very common. So I'm telling you like what's the special of the data here is that the wind speed data here, as you can see there are integers. So if you run the data, it sorted data will give you like data from like 74 to 60 to 56, like a lot of same data, 50, 54, 51, and this will create like staircase like function the PDF. So you need a way to handle it. So there are like more than 700,000 data here. So this is 82 years of daily data. So because we have 82 years, so you do some estimate, like it's a very just like you could guess like 5 data per year. That will give you a good estimate of the tail part of the data. So that will like 82 by 5 is 410. So you just get the 410 data here. That will give you. So this data will be used to do the extreme value analysis. You can see like from 74 to all the way to 30 here, and you want to do the loop here. I did that in the last video. This could take a while here because we have a lot of data here. So I won't do it this way. Like just let me show you what the result look like. So finally you will just get the plot here, showing you the QQ slope and the QQ plot arrow. So you want your slope to be close to be 1 and your arrow to be 0. You cannot find a place that the slope is 1, but it's close to 1, but like the arrow is small here. So the slope is 1, but the arrow is large. That means your QQ plot is shifted towards the X or Y axis. Although the slope is 1, but you have a large arrow there. So you want to make some compromise here. You can get the perfect results here. So 30. There's a main reason. It's like this is not a float data. This is like integer because you have a lot of same data. So that will give you this way. I will show you like the more plots using the WAFO. So you want the QQ slope, like this is like close to 1, and they give you the smallest arrow. This is 34. So we use the 34 as the threshold for the Pico threshold analysis. So like I have here is the threshold is 34. You want to use the WAFO. You need to add the package in your directory, and you do the WAFO here. So this is like feed gen par. You just look at the manual of WAFO. It tell you everything here. Some flags here. The plot them out is very useful. I feel like I love this package. Let me tell you what I mean here. So because you have a similar data. So you have like a lot of staircase. It starts from 0 because you just manage everything by 34. So like you just manage everything by 34 here. That's why like it start from like almost 0 here. Like it's just start from 1 here. It's like because you have like same data for a lot. So like this is the blue line is the empirical CDF. And the black line is the best fitting CDF. So that's why like there is no function will fit this staircase function, and this black line is the best fit. And for the density plot, you want your density to be like all the way decreasing because that's how the GTPD works. You don't want your like the best fit distribution look like this, like increase and decrease. That means that you select too many data. You want to use to decrease and fit the plot here, the box plot here. But in this case, like there's no data. Like just literally, if you compare the dot line versus the black line, you just cannot fit the distribution to that one. So that will give you the best fit. If you look at this one, this QQ plot here, the slope is about 1. The arrow is like close to 0. You can see that here, the similar data. That's why they give you a hard time to do the QQ plot here, and similar to this one. So it shows like 34 is a good selection here. I'm tell you how to calculate the 100-year wind speed and 500-year wind speed. To calculate the 100-year wind speed, you need something called factor. because you have 82 years data and you want to estimate like the 100-year data. So you need to get a factor here. The code is very clear. You just try to like just read the code, do this yourself. Like the threshold is here. Just like when you do this, because you always have integers, you need to add like a very small number here. Otherwise, the mod it won't work. The JP fit cannot work for like 0, like less or equal to 0. You have the threshold here. You do the JP feed and you calculate the 100-year and 500-year data in this way. I did not do this. Okay, let's see. The 100-year is about 69. The 500 years is about 81 knot, which is should be good. You may have a question like why like the maximum is. You may have questions like why the maximum is I think 74 and your 100 years less than that. It's just because the fitting, the nature of the fitting, because your the largest value is 74 and the second largest one is 60, and that's the reason why your just 60, the 74 will just above the curve here. So that will give you like 100-year and 500-year. Hope you enjoyed the video and thanks for watching.